Hi, Math 141 class. So, some of you guys were asking me to do this problem, which is the second part of the quiz. So I'm going to do it right here. So we have this jet flying at 800 miles per hour with a bearing of 20 degrees southwest. And then you have the jet is being struck by a wind at 68 miles per hour at a bearing of 36 degrees southeast. So find the speed of the jet and this new direction that it's headed to. So, remember that what I want to see is two different types of bearings. So we want to be able to see the jet bearing. Okay, so let me just draw the bearing for the jet. So we know that this guy is going at 800 miles per hour southwest. So let me just write my little north, south, west, east signs. So we know that it's going southwest, so it's going this way. And the bearing here is 20 degrees. So remember that the bearing is on the north-south line. This guy is going at 800 miles per hour. Okay, so this guy's for the jet. And then you also want to draw the direction for the wind. So the wind is going at 68 miles per hour southeast. So you have north, south, west, east. And it's going this way. And the bearing is 36 degrees. So this is my wind. It's going at 68 miles per hour. So this guy's for the wind. So what we gotta do is we gotta find the vector form of both the jet and the wind vectors. So I'm gonna say J for jet. Oh god. Okay, so I'm gonna say, not to be confused with the J component. Let me just make A for airplane. Okay, so we know that what we got to do is find the magnitude. Okay, so the magnitude of this vector is going to be 800, because that's the velocity, times the cosine of the direction. Okay, so you have to be very careful with this, because the cosine, or the angle theta, starts from the positive x-axis. So we got to think about all of this angle. Okay, so this is the angle theta that I want. If I see this, you can see that a full circle from here to here is 270 degrees. Okay, that's 270 degrees. And I can subtract that off by this 20 degrees, and that's going to give me the blue line. So if I do blue, it will be 270 degrees minus 20 degrees. Okay, that's going to give me 250 degrees. So that's going to be the thing that I go in here. That goes in here, 250 degrees. And then everything else is going to be the same. So then you have 800 times the sine of this will also be 250 degrees. So you have to do a little bit of geometry there. And then finally we have this wind vector. And then this wind vector is going southeast at 68 miles per hour. So that guy is right there as a magnitude. And now we have to think about what would be the cosine and the sine of this direction. So we got to think about, well, we know that this entire thing is, we just figured out that this was 270 degrees. Well, if I want to go a little bit more over here, well, I have to add this 36 degrees. So I'm taking 270 degrees and I'm adding this additional 360 degrees because I want this whole angle theta. That's going to be the whole entire angle theta. And that's just going to give me 306 degrees. So here goes 306, and here goes 306. All right, so now all we have to do is put this in our calculator. For the A vector, the airplane, I ended up getting negative 273.6, and then negative 751.8. And then for my wind vector, I ended up getting about 40, and then negative 55.01. And one way to know that you got this right is that look at the vector for the airplane, for the jet. You can see that it's in the third quadrant. So then in the third quadrant, both the x-axis and the y value, or the x value and the y value, are both negative. And for the wind vector, you can see that in southeast, you see that the first component is going to be positive, which it is, and then the second component is going to be negative, which also it is. So now all we got to do is figure out the new speed of this airplane. So all we got to do is just add these guys up. So when I add this guy up, I'm going to end up getting negative 233.6 and then negative 806.81. And now remember that this is not what I want, because what I want is the speed. So I want the speed of this guy. And the speed is just going to be equal to the square root of the sum of squares. Negative 233.6 squared plus negative 806.81 squared. So I'm squaring that guy, adding them and taking the square root. And what you end up getting is about 840 miles per hour. That's what you end up getting, or 839.9. So that's what you end up getting. So this will be the speed of the jet, and now all we got to figure out is the direction. So theta in this case is going to be equal to the inverse tangent of the y component, which in this case is negative 806.81, and then the x component, which is negative 233.6. And if you do this, you're going to get a positive number, so 73.85 degrees. Now we have to be very careful because this is not the right answer. The right answer, remember that if you look at the new vector, this guy is in quadrant 3. So we need to figure out what exactly is this new bearing, which is going to be hugging the north-south pole. So what we just found out was, remember that inverse tangent is in quadrant 1, in quadrant 4. So basically the angle that we just found was this guy. We just found this angle, the 73.85 degrees. Okay, so this is not what we want. What we want is this purple one. Now if you do a little bit of geometry, you can see that this guy and this guy are exactly the same. They're both vertical angles. So this is 73.85 degrees. So all we got to figure out now is what exactly is going to be this purple vector. Well, this purple angle. So all we got to do now is that the value of theta will just be equal to 90 degrees, because we know that these are complementary angles, minus this 73.85 degrees. And this theta value is going to be equal to about 16.15 degrees. Now what we got to figure out, we got to put this in bearing form. So what we're going to do is we're going to go ahead and put it in the direction, which in this case it will be southwest. So it'll be southwest, and then the bearing will be 16.15 degrees. Or you can just write 16.15 degrees going in the southwest direction. So you make sure that you always put also the direction as well. So hopefully this helps.